Okay, guys, good morning. Today's lesson is talking about 7.2b in the areas of volume, with something we calculating the surface area of the cone. Someone may be curious why we need to teach cone separately, because for 7.1 the whole things we have calculating the pyramid, and actually after the lessons for 7.2a we just find that this is just a pyramid with the circle base. Okay, so I would like to tell you something about why we need to calculating the cone separately. Because in this part for the surface area, we need to do something different. For example, if we have a triangular base pyramid, we have to calculating the surface area by calculating the three faces for the slime face, and then for the fourth base for the fourth face of the base. And actually you can see for the clone we just have the curved surface area of first part, and then the second part is for the base. And then this is something difficult, is that we have to memorize the formula of the curved surface area. And what is the curved surface area? Which is, for example, if we get a base with the radius r, we have the slime height for this is we call L. The curved surface area, this part, which is pi r L. Okay, for sure the base area should be pi r square. So the first thing we have to memorize is that the cone, the total surface area is pi r L plus the pi r square. Okay, why the curved surface area is in the formula pi r L? I will now show you this. This is a very good activities, I think. Okay, so we do it step by step. By considering the first figure, we get a very usual cone. So actually, what we have written before, the base we get the radius r, and then for the slime height we're using a L to represent. Okay, after the figure 2 we cut it out, we get the sector like this in the figure 3. Okay, don't forget, if we have cut it out, VA and VB, which is the length for in terms of L, just like the figure 1 what we said. So now we're calculating the area of the sector first. Okay, so remember, how can we calculate this kind of sector? Because for the whole circle we have an area of pi r square, but in right here the r is in the length of L, so pi L square for the whole circle in this case. But now we just have, because the whole circle is in 360 degree, we just calculating this part only for theta degree. So we get actually calculating theta out of 360 degree times pi r square. In this case the r is a L, so theta over 360 degree times pi L square is the curved surface area. So actually we can focus on the question of 1b. The curved surface area we now write down is theta over 360 degree times pi L square. Okay, so calculating this, we have to simplify. Okay, now for 2a, the first part, consider the figure 3. We express the arc length for AB in terms of theta and L. Okay, now we can see the same things here, because the whole circle with circumference, we get 2 pi r. In this case, also 2 pi l, right? Okay, so I just need to calculating the part of theta. So theta over 360 times 2 pi l, okay, is the arc length for AB. Okay, so for the part 2, in the figure 1, we're calculating the arc length for AB in terms of r. So this is just circumference. So 2 pi r is actually the arc length for AB. Okay, now you can see we just have the same arc length for AB but expressed into two form. Theta over 360 degree times 2 pi l equals to 2 pi r. So let's simplify this. We cancellating the pi in the both sides. We cancellating 2 in the both sides. So the left hand side we get the theta over 360. So the right hand side we get is r over l. Okay, r over l. So we put it back into this formula. Theta over 360 equals to r over l. So actually we have the second step, r over l times theta r l squared. We cancel one of the l. We still have r. So we get the equation for pi r l. Okay, so if you don't really know what I'm talking about, it's okay, but I think that this is a video, so you can watch it one more time in case you really don't know. This is advantages of the video. But all you need to know is that the curved surface area, we have the formula that pi r l. So for the example 7.9, you can have this. We now need to find out the total surface area. We first calculating the curved part, which is pi r l. In this case, the pi r l is pi with the r is 6, l is 10. Okay, plus pi now square. Okay, so you will see here the curved one, pi r l, 60 pi. The pi r square is pi times 6 square, so 36. 60 pi plus 36 pi, you will have 96 pi square, which is the answer. Okay, so you can see the example of 7.9 is just using the formula directly, and so the quick practice 7.9 you can try it by yourself, but you can see you will get r, we get l. So pi r l plus pi r square. You can simple have the all the numbers. For 4 is the r, 6 is the l, plus pi with the r is 4 square. Okay, then you got the answer. Okay, for the example 7.10, you will see we got a radius of 5. We got a height of 12. We know that the formula of this by just calculating the example 7.9, you will see we need a L. So therefore, this is a right angle triangle for VOA, which is a right angle triangle. So you can using the Pythagoras theorem to find the values of L. So 5 square plus 12 square, you have a square root of this. You will see that this is a length of 13. Okay, after you have find the L, then you can using the same method for example 7.9, just pi r l plus pi r square, then you will have the total surface area. So the quick practice 7.10 is also the same things. So the most difficult part is how to remember the curved surface area to be pi r l. This is the most important things in this part. Okay, so finally, the example 7.11 is the last example that we need to see. Okay, let's see what happens. In these figures, sector VAB is now become a right conical face. Actually, this is the cone, okay, with the height 24 and the capacity is 800 pi. Capacity means that the volume. Okay, let's remember what is the volume of a cone. 1/3 times base area, which is pi r square, and then times height. So now, if we have the volume of 800 pi, that means it's equals to 1/3 times pi r square, and then with a height for 24, and then we have equation like this. Okay, remember what is the r in this case, which is the OA. The r is the base of the cone, and then the radius of this. So we know the radius is 10 now. This is the length of 10. Okay, then remember we're using the arrow, the slide height, to find the curved surface area. Therefore, we're using the Pythagoras theorem again. This is 10, this is 24. We can use Pythagoras theorem just like 7.10. You will see the slide height is 26 actually. Therefore, you can find the curved surface area by pi RL. Pi r with 10, the L we just calculating 26, so 260 pi. Okay, for part C is the most difficult one. Peter claims that the theta is greater than 140 degree. Do you agree with that? Okay, so we know that the curved surface area we just calculating 260 pi, and then we need to find out what is the theta of this sector, this part. And then we just need to compare the same thing is okay, because we want to find the unknowns for theta over 360 times. Okay, you have to know that this is the pi r squared, but in this case the r is the L. This is 26, so r squared. Okay, so you can see that we have to compare 260 pi with these equations. So now I just make it in the equal sign. Then you will find that theta is just equals to 138 degree. So this is the incorrect statement. Okay, so I think that if you know how to memorize the curved surface area of pi RL, then this is not that difficult. So you can try the quick practice 7.9, 7.10, and 7.11, and also the consolidation corner. Okay, so that we finished the 7b. So try to finish this part, quick practice, and also the consolidation corner. And so the exercise on the E-class, please finish it. And then I would like to say, if you really don't know the proof about the curved surface area, you can watch it one more time. And then if you really cannot get it, and then you can't ask me, you can ask me in WhatsApp, or actually you can just memorize the curved surface area is pi RL. Remember, you have to memorize which part is R, which is the base radius, and then the L is the slide height. Then it's okay. Okay, that's all for today.